Welcome everybody. I have one question before I start. Who's a developer or technical? Okay. We hope to not to try not to make it too technical. Today we're going to talk about GPT. My name is Robert. I'm the co-founder and CEO and director of GPT. And that's my colleague Cas. We can introduce yourself.
I can introduce myself, of course. I'm also co-founder of BBT, and I'm more the CTO guy, so more for the technical things is more my part. So I hope I won't keep it not too technical, but I heard it was a workshop, so we are going to calculate some things and we'll do it together. So if everybody can try it or use their phone to calculate a part, then we will manage to get it out.
So basically, what's the reason we started GPT, and this is one of the problems. So if you take a look at AI, the 1% of the world's energy consumption will double by 2030. A large other problem is transparency, and that's basically one of the most, maybe the primary thing we want to solve, is to be really transparent about what is the footprint of AI and how can you set up, let's say, Fernando said sustainable AI, but sustainable AI doesn't exist. So we say sustainable as possible AI provider. And that's what we are trying to do. And that's also what we're going to explain how we do it, also being transparent about how we do it so other people can also replicate or we can help them. Also, another thing which is not transparent, like the footprint is not transparent, the energy uses is not transparent, but also the privacy. So if you use like hyperscalers, other models, Azure, even in Azure, you don't know if they use the data to train the models. So what we are trying to solve is to make a transparent AI provider where you also give the guarantee that we don't train the models with your data. So this is us. So basically, we're from Utrecht. It's also a city in the Netherlands. One of our core values is privacy, environment, quality, and certifications. We got a positive DVIA, that's a data processing impact assessment. The reason for that is that we don't have any processors, only Skillway, which is pretty cool, I think. And also we have a positive AI impact assessment. And we're going to show you how you also can do it. So what is it? So basically, we have a couple of products. One is an AI chat with subscriptions, but basically we're a full stack AI provider where we provide all kinds of AI in our API. We have re-rankers, embedding models, speech to text, router, MCP, and also OCR. And we're currently also busy with Deep Search API, Search API, which is basically all self-hosted. So the thing is with AI, so the problem with the sustainability part of AI is that you don't know if it's sustainable or not because there is no data about the energy usage. So that's also the reason we said, okay, if we want to do this, we need to host ourselves. It's the hard part, it's the expensive part, but that's the only way if you want to know how sustainable you are, you need to own it yourself. So you need to have the GPUs. And that was basically the start of our journey, that we said, okay, we need to have the GPUs ourselves. We have bare metal access to measure it. Today, we're also going to tell something about the calculations. It's a little bit technical, but later on, I will explain what we show. So this is basically, maybe I don't need to tell it, but so basically we don't know how much energy AI costs. These are articles where you wrote about it.
And then I can take it over from here. I think one of the most important things that we do instead of our competitors, we give insights on how much electricity you service. So I get a lot of questions, and you say that you're sustainable, but how much sustainable are you? And that's a really hard question to answer because we don't know either. Because we know how much electricity we use, but we don't know it of the competitors. OpenAI and also Anthropic don't provide the information and how much electricity and your carbon intensity footprint is of your prompts that they are giving. So we are open, we give the information, and we also created a metric. And we really hope that the other bigger companies are also going to provide the information so you can compare and we can really say we are way better. We know we are, but then we can also prove it. So our metric, so what we created a metric, and in that metric we are going to provide the electricity use of a model. So right now there is a metric, and that metric, right now you can see benchmarks of models, but then you don't know where the model is run. So the model is also important in what kind of hardware it is running. So that is a metric we have. It's how much milliwatt hours per 100 tokens, and I will come back a little bit later on this when we go into calculate. So then it's going to be a little bit more boring maybe, but please bear with me. So right now, what we are using the NVIDIA H100s for bigger LLM models. So right now, we did a lot of testing, and we see up and downs in when you're using it. But when you're using it, most of the time, it will produce around 250 watts. On idle, it's around 100. It really a little bit depends, but that's the benchmarks that we created. It's not only a GPU, but it's also a CPU, and that's around 40 watts idle and 80 watts hour when it is running pure inference. So what we can do, what we want to know, because we can measure in real time, and I will show some screenshots of that one, how much the GPU is using. So if we know what the additional costs are, so from Skill you get a PoE, so that's everything besides the server. So for example, we know for the networking part, for the cooling part, but for our side, our server, it's really important to know the electricity part. So we know how much the GPU is using, and we know how much the CPU is using. So we calculate that. And if we calculate that, we will get a rough estimate how much watts the server is running for when it is processing your prompts. So then we calculate it, and then we will get an overhead for this example around 1.2. So if you're running, if the prompt is running, we will use 380 watts. We're still here? Yeah? No questions yet? Okay, cool. Then we will continue. So, right now, if you have 260 watts, you're not running it for an hour. So otherwise you could say you're using 200 watt hours. But most of the time, if you ask a question to an AI, it will serve you in, I think, a few seconds. So we will calculate it a little bit back. We will also divide it by 1,000, so we have milliwatt hours, because otherwise it will be 0.000, for example. So we know for this GPU that we are using that it's around 105 milliwatt hours a second. So then we have that number. Then we need to know how much tokens our model is using. So then we do a lot of benchmarks. We have a lot of benchmarks that we use for multiple models. And then we know how much tokens it will use for running on our server. So for example, right now it was, I think, a minute this benchmark, and we ran for 50,000 tokens. So then we know how much tokens it will cost to run the model. And then we can put it in our metric. So if you put all the numbers there, somebody can confirm this if they have their mobile with you. But then, for example, this is one of our base models. This is our Green L, and it will run for around 11.6 milliwatt hours per 100 tokens. So we have that number, then we know this number, and then we can compare all the models. So if we run multiple models on our server and do these benchmarks, we know which one is the most efficient. But what is also really important, we want this number to go down. So it's not hosting on sustainable hardware, or also the location, we will come back on that one later. So we have a really good hosting provider, Skillway, they're really sustainable, but we also want to influence that the costs will go down of that number. So the number we want to go down. And that's
so that was a little bit the technical part, and I'm going more like the conceptual part. So the thing is, what we say is bigger is not always better, always better. And the thing is, what we do is when we started this, the open source models were getting better and better, and we did some benchmark where you say, if you have like, if you use OpenAI, if you use ChatGPT, basically you drive in a Ferrari to do groceries. So when you use our platform, what we do is we choose more mid-sized models for certain tasks. And the most of the people are using it. I think 95% of the people using AI, they don't need a Ferrari. They don't need like a smaller car for their task. And so that's like basically one thing we do. The other one is what kind of models do we use? So you have like the normal models like they get released by the open source community or by OpenAI. But we also take a look, okay, if there are like prototype version of it, it means that the model is smaller and the output is still good enough. We also choose to use like smaller models for the so that we choose to use smaller models. Yeah. The other thing is maybe it's an easy one. It's more the system prompting. So even in system prompting, we do a lot of experiments where we influence the behavior of the model in the output tokens. So what Gus just explained, in an AI model, you have like, I always say to make it a little bit easy, two things you can measure on. It's the inference time, the time the model is like calculating your answer. And it's the output tokens, how many tokens was the output. And if you can influence that without real contact loss, that's also more sustainable. So that's more in our system prompting. And the other thing is, which is, I think it's super interesting, is the human influence, is, is if you, so what I always tell the story with this is people are bad at prompting, and people are bad at asking questions, even person to person. And the large companies like OpenAI and Claude, they release all kinds of prompt cookbooks, how you should use their product. And basically, that's also a sustainability question. Because if you help the user creating a better starting prompt, it needs to go to the perfect answer. So it's not like a real technical question. It is also more a UX question. So what we also do is we choose the hardware to the model and the model to the hardware. So for example, we for our speech to text, we have DeepGram. So the DeepGram model, we license it from the US. Super cool model, Nova 2, Nova 3. I think it's one of the best speech to text models in the world. But you can't just deploy it on H100 and it works. But you can also deploy it on, it's a small model, on a GPU L40, and which has like it has the same performance. And what's the interesting part is, this is the next one, is that we also have re-ranking models and embedding models. They are small, but they need a lot of compute to get a better performance. So what we do is that we deploy it on a H100, but we split the H100, where we deploy the re-ranker and the embedding model, where you can have one GPU with two models, but still, if you run them, they use the total compute of the H100s, which makes it more efficient. And that's something we're currently exploring a lot. It's more to see, hey, now we are Green Petit, we have this infrastructure, but basically all the AI is everywhere. So you also have like OpenAI and Claude, and we don't think it's really easy to say to companies, yeah, come to us and don't use this frontier model anymore. Like I think, yeah, it's I think it's a hard bet to do that. So basically, we where I think in a lot of cases you can also optimize APIs from other parties. And one of the things that's really interesting is prompt compression. For example, in structured output, if you have like JSON as output, you have techniques to compress the JSON, which makes which you have like the same structured output, but using less filter. So that's something we're currently working on.
then I will take over for the other part. And the other part of being more sustainable is to choose where to run your server. So right now, if you look over here, you can see most of the time. These are bubbles for using data centers. So, for example, you see here that there are really a lot of computers in the US, a lot of computers in China. It really depends also where you put your data center and how efficient or what kind of impact your compute has. So, if you take this map and you put it next to this one, it doesn't. There's no overlap. So you see really the big ones where there's a lot of compute. It's really red. So this is one. This is a map from electricity maps, and where you can see the quantity of your kilowatt hours. So if you run the same compute on the same data center but the location is somewhere else, your impact will be higher or lower. So what we did, we choose our data center, and it's based in Paris, it's based in France, and here the impact of your compute is way lower for the same compute, same model, but only the data center location is in difference. So that's also one of the choices that we do. We do it in Paris and we don't do it in the Netherlands, or we don't do it in the US because of that reason as well. So yeah, we choose Skillway. We use one of their most efficient ones with a really low PoE. For the people that don't know what it is, it's about everything besides running the server itself. So the cooling, the networking, everything without the server is really low on that number. Also, the water consumption is really low, and they use 100% renewable energy.
Yeah, just want to take disclaimer of 100% renewable. That is not always 100% renewable. It's an ISO normation. So I think it's 90% renewable and 10% the grid gives other electricity, and in France, that's most of the time it's nuclear, and then it's going. Just so yeah,
Little disclaimer.
yeah.
So yeah, for us, big part was okay. We have our AI, we are running our models, but then also, what for us was also important for what kind of partners do we have. So, for example, if we need a login page, is that partner has the same ideals that we have in privacy and in sustainability? Then you have to talk to them, you have to get the numbers, you have to trust them, and all other services. So we're thinking, yeah, why not do it all ourselves? So we do everything ourselves. So the logging is from us, the search is from us, everything we do ourselves. So we know for sure that it is as sustainable as possible in location-wise and also in privacy-wise. And how we did that with, a ton of open source. So we just looked who is doing this, what kind of packages are available that we can host ourselves. So all those packages made our service, or most of them. Of course, we made a lot of our own code, but we use a lot of open source, and that helps because we don't have to have a data license agreement with them, and we know for sure this is as sustainable as possible. So then we talk a lot about benchmarking. I need to be a little bit more quick, so we do it also in real time. So we're giving this information back. So we have our dashboards, so we can see what's really happening on the server. You can also give that back to the user, and we do that in our chat as well. So in our chat, you can see on your prompt, so you have a whole prompt, you can see how much CO2 and how much kilowatt hours it used. And you can also see it for your past 30 days. But also we give this back in the API. So every time if somebody's using our API, we also give back how much energy uses it was at that time. And I think that was also a little bit the end of the story. So this is where we are. If you have any questions, come on by later or right now. I don't know if there is time for now.
Excuse me, I have a question. Do you know the difference of the energy source that you're using? You said nuclear in France, but I mean, sustainable or not? Isn't the source of the energy important?
Yeah, so the funny thing is, we are working on that right now to make it more connected also to the day of the moment in the day. We're using AI to so that we use the difference and also where the energy comes from. People have questions? Yeah.
I'll try to be very loud. So thank you for the presentation. I wanted to ask about the formula for calculating the megawatt hours per 100 tokens. Thank you. So you mentioned that you use PLLM as the inference backend, which is very good at request batching.
Yeah.
So I wanted to ask you if you took into account request batching when calculating the energy consumption per 100 tokens. and how you did that, because it's very interesting to me.
That's a really good question. I think it's also more a technical one. So it's more asking how did we do the benchmarking? Is it one user or is it multiple users running at the same time? So for us right now, we wanted to be as transparent as possible. And I think we use the worst scenario possible because then it can only be better in some criteria. So what we did, there's only one user running on that server, and it's not this most of the time not happening at our server. So we have of course multiple clients and multiple users using it. So what we are doing, we're giving them a number, and that number is most of the time too high. But yeah, then we know for sure that it is not too low, because otherwise you're given guarantee that that your impact is less than it is. So what we are also doing now, but it's not for the benchmarking, but more for the real-time usage. We're trying to divide that number by the amount of users running it at that time. So that's not for the benchmarking part, but it's more for the real-time part. We want to give a more real number that's a little bit less. That is lower.
Thank you.
Sorry. You mentioned in the beginning privacy are risk and other models, but you didn't emphasize enough like how is yours different from the others.
I think it's not only about running the model, but it's also about we run the models. We don't. There's no connection with somebody else, and the other ones are training with they have an incentive to use that data to train other models because they are making that model. So we don't have that incentive. So we don't want to have that data. We just process it, and then afterwards, of course, in the chat we save it for you so you can see your chats. But in our API, we just delete it. We don't have an incentive to have that data.
Okay, thank you.